Hi guys, my name is Bappi Ahmed and welcome to my YouTube channel. So guys, in this video, I will show you how we can train this YOLO11 model on top of our custom data. So here we'll be training this model for the object detection task. Okay, so I think you already know Alterytics published this YOLO11 model. Okay, YOLO11 model, and with the help of that, we can perform object detection, classification, segmentation, then pose estimation, then oriented bounding box. Okay, so these kinds of tasks we can perform. And I already created one video in my channel, so there I already showed you how we can use this model to perform different kinds of tasks. So if you haven't checked that video, guys, please try to check this video. You will get the entire understanding of the YOLO11. Now let me show you how we can perform the custom training operation. So I already prepared one notebook. So let me first of all connect this notebook, and resources would be shared in the description section. From there you can download. Okay, so what I will do, I will select the T4 GPU here. So this is the free GPU you actually will get if you're using free Collab. Now let me connect the notebook. And let me show you the data, guys. The data set actually I'm going to use for this training purpose. So this is the link I have given. So this data set is available inside RoboFlow universe. So I already showed you what is RoboFlow. RoboFlow is a actually platform, computer vision platform. Let me show you the RoboFlow, roboflow.com. So it's a computer vision platform. So it provides actually all kinds of functionality, all kinds of tools and technology for the computer vision. Okay, so it is having one amazing platform called Universe. Okay, let me open the Universe. So this is the Universe, guys. So inside Universe, actually we are having different kinds of computer vision related data. Let's say you want to perform object detection, image segmentation, okay, classification, all kinds of data, all kinds of category are available. Let's say I want to perform object detection. Just try to click here and you will get all the object detection related data. Now here you can also search like what kinds of data you need. So here I'm going to use one data. So this is the data, guys. The data name is PPE detection dataset. Now if I show you the image actually, so guys, you can see this is the image. So actually this image was collected from a factory. So inside factory, actually there are some employees. So they are wearing different kinds of safety gears like helmet, then gloves, then boots, then jackets. Okay. So we have to detect these kinds of safety gears. Okay. So this is the data. Now you can also see any other image as well. Okay. See, this different kinds of image actually we are having. So this is the data set actually I will be using to perform this kinds of object detection task. And you can see this object is actually a little bit smaller, but still this YOLO11 model will be able to detect that object. Okay, after training, let's say 50 to 60 per, it will able to detect that object. I'll tell you. Let me show you first of all. Now, if you want to get the data from the RoboFlow universe, just click on the overview, and there is a button you will get called download project. Just try to click here. And there you will see one option called download dataset. And see, all the dataset is already annotated here. You don't need to annotate it. If you want to annotate the data, so I already created one video in my YouTube channel. There I showed you how to annotate the data as well. So guys, you can see this is the video I created, how to perform the annotation with the help of RoboFlow. So this video actually you can check. Now let me show you next what we'll do. First of all, let me check the GPU configuration. So here I got Tesla T4 GPU. Now the second thing, you have to install the Alterytics, because I already told you this YOLO11 is available inside Alterytics. So we'll be using Alterytics package for this. All right, now if you want to check the Alterytics version and Torch version, Python version, so you can execute this command. Now guys, you can see it is giving you all kinds of version like Alterytics version, Python version, Torch version. Okay, now let's say you want to set up everything in your local machine. So you can see the version with respect to that, you can set up everything in your local machine. Got it? Now let me import some of the necessary library. I'm importing YOLO as well as the image from the display itself. Now, if you want to get the data, so I already told you, just click on the download dataset, and here you will see the format. So try to select the YOLOv11 format. Now click on the show download code. You can also download as a zip file, but I will download with the help of code. Now if I click on continue, so it will give me the source code. So now just try to copy and just try to paste it here. Okay. So this code snippet will automatically download the data from the RoboFlow universe. Now let me show you if I execute the program. See, left hand side you will see that it will download the data. See, PPE detection data, and inside that you will have all the images, everything it will have. So guys, as you can see, my data is downloaded. Now you can see we are having three different folder: test, train, and validation. So this is the same kinds of data. I think previously if you have used YOLOv5, YOLOv6, so this kinds of data we also used to use. I think you remember, right? So it is having the image folder and it is having the label folder. Okay, inside image we are having all the image, inside label we are having all the TXT annotation. Okay, now it is also having one file called data.yaml. Let me show you. So this is the data.yaml, and inside that they have mentioned the data path, like what is the image path, and the number of classes. It is having same number of classes, like you can see dust, mask, eyewear, glove, jacket, protective boots, protective helmet, and shield. So these are the actually 7 classes actually this dataset is having. So now what you have to do, guys, you have to change the location of your data. So here you can see my data is present inside my collab. Now I just need to change the location. So let me show you. So just try to copy the image path and just try to mention it here. For the validation as well, let me open the validation folder, copy the image path and try to mention it here. Then I will also do it for the test as well. So only this change actually you have to do. Now let me save with the help of Ctrl S. Now let me close it. Now if you want to see the data location, so you can also see the data location. Now guys, we'll start the training and see that much actually easy it is. So you don't need to do so many configuration. So everything is already done by Alterytics. So you just need to start the training. So for this, you have to execute one command called YOLO, and you have to specify the task. Let's say I want to perform detection task here, right? I will give detect. Mode is equal to train. I want to train the model. And this is the data location I'm providing. That means my data.yaml file path. Inside that I'm having all the path, right? All the image path. Now I'm giving the model name. So which model you want to use? I already told you it is having different kinds of model, right? So you can give any kinds of model. Let's say I'm performing detection. So just try to check the detection model. So I'm using nano model here. So you can see I'm giving the nano model. And number of epoch, I want to train only 50 epoch. And image size 640. That means during training this YOLO11, they used actually 640 dimensional image. So that's why I'm passing this size actually. Now if I click here, so it will start the training. See, first of all, it will download the model. Then after that, it will load the data. Then it will start the training. Let me show you. So guys, as you can see, my training has started. So epoch is running. So it will take some time. So let's wait. Once training is complete, I will come back. So guys, as you can see, my training is completed. Now, if I refresh, you will see one folder called runs. Inside that, it has saved all the artifact. Let me show you detection, train, and inside void folder, you are having the train void. That means base.pt. Okay, this is my model. This model I will be using for the inference. Apart from that, it has also saved all the, let's say, like evaluation matrices and all. So let me plot some of the matrices and let me show you the model performance. So first of all, if you want to see the confusion matrix, multi-class confusion matrix, you can also see that. So how we can understand this confusion matrix? Let's say, so you can see glove actually written 54 time, but here you can see my model has done one mistake. Actually, it has only predicted one time. Actually, it's a shield. So that's how actually you can understand this multi-class confusion matrix. Apart from that, if you want to like plot the levels, like how many levels actually you are having in each class. So this is the distribution. So we are having 7 classes and shield is like very less. Okay, in that example. Now, apart from that, you can see the complete evaluation matrix. That means the training losses, MAP score. See, as per your epoch is increasing, loss is decreasing, epoch is increasing, MAP is also increasing. Okay, that means my model learning is good. Apart from that, you can also plot some batch images. You can see these are some batch images. Okay. Now see some batch images. Even in the runtime, it also performs the augmentation technique, right? Now you can see some batch images as well. Okay, so these are some batch images. Now let's perform the validation. That means if you want to check the validation score on top of the validation data, so execute this line. So it will do the validation operation. So it will load my actually trained model. So you can see I am giving my model location. So this is the model location. Just copy the path. Okay, copy the path and try to paste it here and give the data location. It will automatically pick up the validation data. And if I execute, you will see that it will give you the complete, matrices, like what is the MAP score for each class, everything it will show you. So see guys, this is the validation score and this is the, so guys, you can see this is the results and this is the MAP score actually I'm getting. So MAP score should be actually close to 1. That means your model is performing better. Now let's do some inference operation. So here I'm giving my test data. You can see test data location. And this is the model actually I'm using, my trained model. Now if I perform the prediction on top of it, now let's try to see whether it is able to detect that object or not. See, it is detecting all the data and it is saving in the folder. Which folder? Just open the detect folder. Inside that you will see predict, and inside that all the prediction would be saved. Okay, now let me show you some of the detection. So this code will actually load actually 3 to 4 images and it will show you the detection. See, so guys, you can see it has detected jacket, eyewear. Then you can see also it has detected protective shield, protective helmet, gloves. Yeah, so it is able to detect because you have only trained 50 bucks, but still it is able to detect everything. Now also let me download one data actually I'm having. So in this URL actually I'm having one data. So this is the image actually, that factory image. On top of that, I will perform the detection. So again, give the data location. See, I've already downloaded with the help of G-down, and this is the data. See, this is the image I downloaded. Now let me pass this image. Now I'm executing the same command, right? Now let me execute and let me show you. Now it will save inside predict2. That means it will create another prediction folder inside detect, because you have done multiple prediction, right? So every time it will create the version. Now inside that you will have the results. Now let me plot these results. So this is the results, guys. See, amazing detection. Now you can also perform on top of the video. So let me download one video. So in this URL, I'm having one video. I'm downloading with the help of G-down. So it has downloaded. Now, see, there is another video you can also download, but I'm not going to download. I'm only going to download one video. Now let's perform the detection on top of the video. So here you have to give the video location. Now see, if I execute, it will show you the, see, it will actually, first of all, get all the frame from the video, then it will perform the detection operation. So it is having 310 frame, okay, in this video. Now let's say you want to render the results in your Google Colab, you can execute this code. First of all, I'm loading my actually predicted video. Let me show you in the runs folder. Detect predict 3. So this is the video. Okay, it has my model has given me, okay, after detection. So I'm loading it, then I'm performing the compressed operation. That means then after loading this video, what I'm doing, guys, I'm performing the compression operation because this video size is a little bit high. Okay, I'm just trying to reduce the video size. So execute this code. So after reducing, it will show in the Google Colab. You can also download and you can also see that. So I already downloaded. Let me show you. So guys, this is the results. Okay, you can see this is the results and it is detecting real time. Okay, detecting real time. You can also use your camera. If you want to use your camera, what you need to do, you just need to pass 0 here. In the source, you just need to pass 0 here. It will open up your camera. But make sure you're running the code from the local machine because I'm running in the Colab. So Colab can't access my camera, right? So you have to execute from your local machine, then it will open up your camera and it will do the real-time detection there. So guys, here is my results. Now we can also play here. See, this is the output I got from my model. Amazing. So that's how, guys, you can perform the custom training if you have any custom data with the help of this YOLO11, right? So in future, I will also create some of the video like how we can perform the segmentation, like how we can train our segmentation model, pose estimation model. We'll be learning each and everything. With that, guys, thank you so much. And if you like my content, so please try to subscribe, try to share. With that, guys, thank you so much. And I will see you next time.